Okay, here we're going to talk about the molar mass of a compound, which we started in chapter 3. Now, this is a continuation of section 3.8, formula mass and the mole concept for compounds. So, from chapter 2, you remembered that the element's molar mass, which was the mass in grams of 1 mole of its atoms, was equal to its atomic mass. From there, we use the molar mass in combination with Avogadro's number to determine the number of atoms in that particular element. From there, the same idea would apply to compounds when we want to find the molar mass of a compound. So we could say the molar mass of a compound is equal to 1 mole of its molecules, and the book uses the terminology of formula units, which is essentially 1 mole is equal to its formula mass. So rather than using atomic mass units as we did for formula mass, we will use grams for molar mass. Now, at this point, we want to keep the terminology pretty simple. We want to keep the terminology pretty simple in that molar mass is essentially molar mass is essentially the same thing as formula weight, formula mass, molecular mass, and molecular weight. Those connotations take the same thing as molar mass. So we will be concerned with molar mass from this point on. So we just finished talking about formula weight. So now let's talk about the molar mass. Now, let's take a simple example, and I did this exact same one in class. We want to find the molar mass of CH4. How do we find the molar mass of CH4? Well, the first thing we need to do is we need to count up each atom in the compound and figure out how it contributes to the molar mass. So in this instance, we have 1 carbon. Okay? And we have 4 hydrogen. So, just as we did with formula mass, we want to take the atomic mass of carbon, which is 12 grams, plus we want to take the atomic mass of hydrogen, which is 1 gram. Now notice that this number 4 corresponds to the number of atoms we have in our molecule. So that it's 4 hydrogen atoms. I'm writing this 2 different ways so you can see exactly what I'm doing. And this 1 corresponds to 1 carbon atom. And when we have the subscript of 1, we omit it from notation, so we don't write it, period. So the total molar mass for CH4 would be 12 grams plus 4 times 1 gram. So that would be 4 times 1 for each atom of hydrogen, and that would equal to a total of 16 grams. So the way the book, your textbook, does it, and this is the way I would expect you to practice and do it. So after we found the molar mass, we want to write out our equivalency or our equal statement, which says that 1 mole of CH4 is equal to 16 grams of CH4. Okay. Now, let me come up here, and sometimes you will see another notation that we have 16 grams per mole in reference to CH4, which means we have 16 grams of CH4 to 1 mole of CH4. Okay, we learned from chapter 1 that anytime we have an equivalent statement or an equation, that we can use that as a conversion factor. This is very important because we will be going from grams of a compound to moles of a compound, and from moles of a compound to grams of a compound, and from moles of a compound to the number of molecules of a compound. I will do that in a later video, but for now we want to stick to the convention of calculating the molar mass and how we're going to write this equivalent statement of moles of a compound and the grams of a compound. So let me do another example. See how fast we can get rid of this. Okay, got a nice fresh whiteboard. I like what we have in class. So let's do another example. Let's calculate the molar mass of C3H8. You can pause the video and see if you can get the molar mass of C3H8. Okay, everybody's unpaused it. So we have, yes, we want to keep the current scheme. Don't interrupt us anymore. Okay, so now everybody's paused the video and they tried it. Let's see if we get the same answer. So we have 3 carbon atoms, plus we have 8 hydrogen atoms. Now we want to take the atomic masses from the periodic table. And that's one reason I put this modified periodic table here so you can see where we get our numbers from. Okay, so we have 3 carbon atoms at an atomic mass of, we're going to round it to 12 grams. And we have what? 8 hydrogen atoms at an atomic mass of 1 gram each. Now we won't be rounding all of these. I'm doing this for simplicity. But in general, we will not round these, or we will round these to a couple of decimal places. Now, so we have what? 36 plus 8, and that is equal to 44 grams. So we are not finished at this point. We need to come and write 1 mole of C3H8 is equal to 44 grams of C3H8. At this point, we can say we finished calculating the molar mass. Now, for this reason of going back and forth from grams to moles and moles to grams, which we've already done, this is the reason I explicitly want you to write this equation out for moles and grams. Okay, so let's see if we can try another problem. And one thing that I would like you to do is to practice various compounds calculating the molar mass. And when I say practice, I do not mean glance at your notes and do what we did in class. I mean go to your quizzes, go to the back of the textbook, and practice problems. The odd number problems have answers in the back of the textbook. So practice writing them out over and over and over again. You should have a stack of scratch paper where you have practice problems, writing them over and over again. So let's take this problem. Let's take PCl5. PCl5. And we just finished naming this compound, which is molecular, and it's phosphorus pentachloride, as you remember. So let's calculate the molar mass of it. So we have 1 phosphorus atom plus 5 chlorine atoms. Okay, so now we have to go to our periodic table, and we have to look at the atomic mass of phosphorus, and we have to look at the atomic mass of chlorine. Why? Because those two make up this compound. So the atomic mass of phosphorus is what? We can round it to 31 grams. And chlorine, we have 5 5 atoms, which comes from what? The formula 5, and its atomic mass is what? 35.5 grams. Okay, so we simply do this multiplication and addition, and you should get 208.5 grams. Are we finished? No, we are not finished. We need to write out 1 mole of PCl5 is equal to 208.5 grams of PCl5. At that point, you have calculated the molar mass of PCl5. Okay, let's try another problem. So one thing that you should pick up on is that you will need a periodic table to calculate the molar mass. You will need a periodic table to calculate molar masses. Okay, let's try this compound. Let's say Al2O3. And we just got through naming this compound, and as a reminder, this is what? Aluminum oxide. This is aluminum oxide. So what do we have here in this compound? We have 2 atoms of aluminum. Is that correct? Plus we have 3 atoms of oxygen. 3 oxygen atoms. So what we need to do is refer to our handy periodic table and get the atomic mass of aluminum, and we need to get the atomic mass of oxygen. These are the atoms that make up this what? Compound. So we take 2 times the atomic mass of aluminum is 26.982. I just round that to 27 grams. Plus 3 times the atomic mass of what? Oxygen. And on this periodic table is 15.999. We'll just round that to a convenient 16 grams. And that is equal to what? Let me just come down here and say that would be 54 grams plus 48 grams. And that's equal to 102 grams. And we can write 1 mole of aluminum oxide is equal to 102 grams of aluminum oxide. And 3 goes there. And that's a 3. Okay, so at that point, this meter, Just say, well, now. And if you notice, this is the same convention or the same format that your textbook uses. And I will refer to the way things are written in the textbook very often, since that will be your guide um, to work these problems. Now, let me see, can we try another problem? Yeah, let's try one more problem. I wanted to stick to atoms that we had on this small abbreviated periodic table, but I think after the first couple examples you get the idea that you need a periodic table, so I can branch off into something that's not on this periodic table. Let's try this compound. Let's say we have Fe2 Cr2O7 3. Now this is a part of this chapter, and you remember that this is what, iron 3 dichrome 8. That is the name of that compound. You recognize this polyatomic ion as being Cr2O7 with a 2 minus charge. Okay. Now let's get back to the business of calculating the molar mass for this. So we look at this and we see we have what? 2 iron atoms. Okay? Plus, let's do the chromates. We have a parentheses and a 2, subscript of 2, and a 3 outside the parentheses. So much like what you would do in algebra, you would multiply what's outside the parentheses with what's inside the parentheses. So we have 3 times 2. That gives us a total of 6 chromate atoms. Chromium, excuse me. 6 chromium atoms. Now, how many oxygen atoms do we have? Well, we have a subscript of 7, and on the outside of the parentheses we have 3, so that gives us a total of 21 oxygen atoms. So now let's come below and put in some atomic masses for these things. So iron, which is not on this abbreviated periodic table, it has a mass of 55.6 grams. And chromium, which is not on this abbreviated periodic table, it has an atomic mass of 52 grams. And oxygen has an atomic mass of 16 grams. So when we multiply 2 times 55.6 plus 6 times 52 plus 21 times 16, we get a total of 759.2 grams. So we can come out here and write 1 mole of Fe2 Cr2O73, 1 mole of iron 3 dichromate is equal to 759.2 grams of iron 3 dichromate. So at that point, we are finished when we have calculated the molar mass. Now, it's very important that we know how to calculate the molar mass, because in class we have already begun to do what? Go back and forth from grams to moles and from moles to molecules, and we've gone from molecules to moles to grams, and we've gone from grams to moles. So this rather short and simple video was to show you how to calculate the molar mass of a compound. Okay, so in my next video I will put some specific problems dealing with going from grams of a compound to moles of a compound to molecules of a compound, and we can go from molecules to moles to gram. Okay, and we can also go from what? Grams to moles, and we can go from what? Moles to grams. But the first thing that we must do is know how to calculate the molar mass. We must know how to calculate the molar mass. If our molar mass is incorrect, then when we calculate the number of grams of a compound, the moles of a compound, or the molecules of a compound, it would be incorrect if we had the incorrect molar mass. So practice these problems. I did assign homework, and this will be on your test definitely, and you will see a couple of these problems on your next quiz. So definitely get in the habit of calculating the molar mass. Now let me say this: if I give you a problem and I want you to find the number of grams, and I give you, say, question mark number of grams, and I give you the number of moles. This going from moles to number of grams, this incorporates calculating the molar mass. I don't have to give you a question to say calculate the molar mass. I can ask you to go from grams of a compound to moles of a compound, or moles of a compound to grams of a compound, and that in itself will test your ability to calculate the molar mass. Okay, so this is just step one in a series of problems that you will have to solve. Okay, so practice it, and if there are any questions or comments, bring them to me in class, to my office, or see one of our tutors, or you can come to the sessions on Monday and Wednesday from 1 to 4.